Okay, finally, two-tailed tests on the geometric distribution. So I've tried to keep the example succinct. We've got a coin flipped repeatedly until it lands on heads, and do a trial and get tails, 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 heads. We want to test at the 5% significance level whether this suggests the coin is biased. So if X is geometrically distributed, probability of success is 0.5. I've just sketched a shape of the distribution, so the probability you get your first success on the first flip would be 0.5. The probability the first head is on the second is 0.25, and so on. So these probabilities are going to halve as you go along, and we're essentially here with X equaling 5. So setting up the hypothesis, the null hypothesis is P equals a half. The alternative is also is that P does not equal a half. We're not saying is it biased towards heads or biased towards tails, we're just testing to see whether it's biased or not, which is your two-tailed test, where P is the probability the coin lands on heads. So always define your parameters. So it's in the wording as to whether it's two-tailed. You need to check both tails. To be fair, you can see the probability of being less than or equal to 5 is going to be bigger than the significance level. But I would just show you're working for that anyway. So the probability X is less than or equal to 5. So that's the probability of being in the left-hand tail of the distribution. So it's the probability of a result as extreme as 5 or more extreme. So that's going to be equal to 1 minus the first 5 all being tails, which is 0.5 to the 5. And that gives you 0.969. We're expecting quite a big probability there. Two-tailed tests, you need to split the significance level in half. So you don't compare with 5%, you compare with 2.5%. So it seems slightly ridiculous comparing this with 2.5% because it's so much bigger, but that's definitely not going to be a significant value. And then check your right-hand tail. So right-hand tail will be probability X is greater than or equal to 5. And that's the probability the first 4 are tails, so 0.5 to the power 4. That gives you 6.25%, which is also bigger than 2.5%. So significance level split in half. And so we're accepting the null here. If this probability here had come out less than 2.5, then you'd accept the alternative, and there's evidence to suggest the coin is biased, but you don't say which way. So we're accepting the null. There is insufficient evidence. To suggest the coin is biased. You also need to be able to find the critical region on the two-tailed test. It's the same as what you did before, you're just comparing with 2.5% instead of 5%, so it's 2.5% each tail. So for the left-hand tail, I'm finding the critical regions. For this one here, you can see actually that because P is bigger than 2.5%, so 0.025, there's not going to be a critical region on the left-hand tail. You need P to be smaller than the significance level for that to happen. I'll run you through the maths anyway, just to remind you. So if you try to find the probability of x being less than or equal to c, and we need that to be less than 0.025, then 1 minus the probability of them all being tails needs to be less than 0.025. And then rearranging that, you end up with 0.5 to the c being bigger than 0.975, which is quite clearly not possible. You could take logs of both sides, and you'll end up with c having to be smaller than 0.0365, and c can't be 0. The smallest value c can take is 1. Alternatively, you could just say the probability x less than or equal to 1 equals 0.5, which is bigger than the significance level, so no critical region. On left-hand side. Remember, c can't be 0. You could just write that as x equals 1 if you want to. And then for your right-hand tail, I'll change colour only because that pen's running out. So we want the probability x greater than or equal to c for the right-hand tail to be less than 0.025. If x is greater than or equal to c, that means the first c minus 1 would have been tails, which takes us to there. And then take logs of both sides. You can take natural logarithms or logs to any base. So taking logs of both sides. Should be right with this bit of maths now. Bringing down the c minus 1, and then when you divide by log of 0.5, you need to remember to flip that sign. Sorry, I forgot to write my log in. So c minus 1 is bigger than log 0.025 divided by log 0.5, and so c minus 1 is bigger than 5.32, and so c is bigger than 6.32. C just takes integer values, and so the critical region is x greater than or equal to 7. So two-tailed test, just combining what you've done before, and just split the significance level in half on each tail. And remember, you're not trying to say which way the bias is, you're just trying to say, is it biased or not? And no further conclusions from that. Okay? So you can see that? Yeah.